Hello, my name is Marvin Bulaker and today is June 18th, 2018, around 1 p.m. and today I'm doing the final project for programming and logic. So we were asked to simulate our factory flow. As you can see here, I have 3 stations. The first one will be loading and it's user operated using the push button. Whenever the operator finishes the procedure, they push a button to allow it to move to the next station, which is the dimensioning, which uses laser curtain and laser lights to measure the product. So I have a photoresistor there to check the light values. And then the final station will be the weighing. I have a pressure sensor there to check the reading of the weight. And on the other side I have the assembly station, which assembles it 2 parts, because the flow was you send it through processes and then the last part has to wait, and then when it gets there, when you get 2 parts in the assembly point, then the assembly happens. On the other side I have a conveyor belt, which is represented by this motor over here, and I use an opto isolator right there separate the two, and that one is running off the 9-volt battery instead of the Arduino. That way the motor does not affect the rest of the circuit. So that's with the DC part of it. Now to get to the software part, I will start by just showing you I have the Arduino software there, and I have the serial monitor here which communicates. So the first thing it will tell you is solid red lights means backup in the system. The green light shows there's sessions in process. Flashing green light shows the ready state for all the stations, and then the blue light shows that the assembly is in process. So to start the procedure, you have to enter an integer that's not 0 to start the factory flow. So I'll do that. And then the motor comes on, showing the conveyor belt is moving, and then all stations are ready. And then you'll notice there's a red light coming up which shows there's a backup that comes up momentarily if the operator has not yet pushed the button. So I'll do that, and then the procedure is done, so it'll start flashing again to show that it's ready for the next process. Same thing here on the serial monitor, and then I will proceed to the next setup. So the motor ran, and now we're back to station 1, which needs the button push, and then we need the second station is the one that uses the laser light, and you can see there's a backup there, so I'll have to satisfy that. The laser light shines, and then we're on to the next stations, and then we'll need to get the conveyor to move again. So we hit the conveyor belt, motor's on, and then station 1 needs a button push, station 2 needs laser light, and now we have the third station. The red light comes on, and this is the one that requires the pressure. So up to that station, the serial monitor communicates what we are doing at every moment. So loading material, dimensioning, weighing, and when it's done, it tells you that procedure is done. And then we come to finish the first part. So the conveyor goes. As usual, we need to satisfy all 3 conditions. This should be, in a real factory situation, this should be happening instantaneously, checking all the sensors at the same time, but here I have to do it manually, one by one. And then we have one part in the system, so we get the system to do it again. Motor's conveyor belt is moving, lights are ready, and this time, because we have 2 parts, the assembly comes on. As usual, we have to satisfy all other 3 conditions to proceed. Now we see what communicated those. The second part was ready, and then now that the assembly happened, there's 1 product in the warehouse. So I use user inputs to slow down between each part, so you can be able to narrate what's going on the other side. But in the final version, I will take off the user input and just let the process run automatically without any necessarily going into input integers after every procedure stop. So you got ready state. Now we have one part. So since we only have one part in assembly, the assembly does not occur. As you can see, the blue light's not coming on. But in the next one, the next iteration, the next send, you will see that the user operated, the loading's done, cutting and dimensioning, weighing's done, and the assembly station came also. Alright, so we will keep doing that. As we see, the inventory keeps counting how many products have actually been sent to the warehouse. So let me narrate to you what's going on with the program itself. So in the first part, we just have the pins. Use motor, red 1, green 1, red 2, green 2, red 3, green 3. Button press, I have the blue one, and then I have an array for the pins. I use that to save memory when setting up the outputs. I have the 2, 1, 2 analog inputs for the photoresistor and the pinch press. And then I have the rest of the global variables, which are the button states, the inventory, the pinch and pinch exits. Those are used for exiting loops. And then I have the Boolean state, which I use to blink the LED. So the setup is fairly easy. I use a for loop to set up all the output pins, the 8 of them. So that breaks down 8 lines into 3 lines, which is good. And then I have the button press, which is the only other input. And then also there is where I give instructions about what the LED lights mean. And then for the main loop, it's really short. It's only 10 lines, less than that, 9 lines actually, because all it's doing is if you don't have inventory yet, it'll go through the process, state A, state B, state C, D, E, and then after that I'll go D, E, D, E, D, E until the system's shut off. So the first function here is input confirm. It waits for the user input to continue. You have to send something to the serial monitor to proceed from there. And then the requested one is what waits. It keeps the loop there until the condition is satisfied by sending an integer which is not equal to 0. I have the function for the conveyor, which turns the motor on and turns the motor off. And after that I have the user input, which it's there to show you when the stations are ready to proceed to the next step. I have the 3 processes here. The first one is loading, which is user dependent, operator dependent, and there I have to when the operator satisfies the condition, you have to push the button. The dimensions, that one's the one that's dependent on the laser light and the photoresistor. And then I have the weighing, which also is dependent on the pressure sensor. So the parts checks for every parts, the number of parts that are in for assembly. Parts count adds up the number of parts. Assemble is the one that represents the assembly happening. I have the inventory check, which the function that checks the state of the inventory variable. So it checks how many products are in the warehouse. And then I have the ready state, which uses the blinking using Boolean to blink the LED to show that the next station is ready. As above, I have the button check to check the buttons. I have pincher, which uses the analog read of the pinch of the pressure sensor to satisfy the condition and leave the loop. So that's if there's a backup, the red light will go on. And then the laser, same thing, but this time I'm using a photoresistor for the analog read. And here comes the functions that reduce my main loop and turn it to be quite short. So in void A, I just put in the loading function because that's the main thing I need. I just need, in the first state, I need to input the command, the conveyor to move, and then the loads to stop. And then for B, it's similar to A, but this time I also add the dimension. So for B, it'll do 2 processes. C, now all 3 processes are put in to the system. So you'll have the loading, dimensions, and weighing. And step 4, you want loading, dimensioning, weighing, and then the fast part is held. And then the count of the parts go up using the parts count function. And it also checks the inventory, which will be 0 in the first case. And then void E is where, process E, state E is where you have your assembly, your loading, your dimension, and your weighing together with the assembly happening. And with each assembly, the inventory goes up by 1. So it is quite a complicated affair, but it looks like a lot of work. But the main loop is the impressive part about it, because it's just those few lines that let the whole communication occur. Alright, I'll have more information on the write-up, and I'll be able to explain more. Alright, thank you.